Hello, this is Maths with Lemon, and in this topic we will see the exponents and their laws. We will start with the basic law, which is a to the power of 0, which is always 1. For example, 2 to the power of 0 is going to be 1, or 1 million to the power of 0 is 1, or minus 2 to the power of 0 is also 1. But here, remember, minus 2 to the power of 0 is 1, minus 1. Why? Because here 2 to the power of 0 is the exponent, and minus is outside of this calculation. Here minus, the sign is under the power of 0, so that's why it's 1. Now the next obvious property, a to the power of n, it means a times a times a times a. How many times? N. 2 to the power of n, it means 2 times 2 times 2 times times. How many times? N times. An example, 2 to the power of 3 is going to be 2 times 2 times 2, which is 8. A little bit further down. Now, the other property is a to the power of minus n, which is equal 1 over a to the power of n, meaning 2 to the power of minus 3 is equal 1 over 2 to the power of 3, which is 1 over 8. The opposite, we will see it many times. If I have 1 over 9, I can write it 1 over 3 to the power of 2, which is also equal with 3 to the power of minus 2. Now here there are some little bit more complicated cases, like for example, if they will give me that 1 over 2 to the power of minus 3. Now here, if I will apply immediately this law, n here is minus 3, so basically this one should be 2 to the power of minus 3. So basically it's 2 to the power of plus 3, which is 8. Let's see that with a different angle. I can write this 1 over 2 to the power of minus 3, 1 over 2 to the power of 3. So basically I use the property only for the denominator, which is this thing. Now this is a composite fraction, so basically I can write it 1 over 1, I write 1 as a fraction, over 1 over 2 to the power of 3. Then I apply the simplification of a composite fraction, which is what? The outside parts of the fractions, 1 times 2 to the power of 3, over the inside 1 times 1, which is 2 to the power of 3, which is 8. More complicated way, but you may find some problems where you have to follow this procedure. We will see them further down. The other one is another also important property, 2 to the power, not 2, let's use a to the power of n over m. Now here this is equal with m square root of a to the power of n. So for example, 2 to the power of 4 over 5. This means 5 fifth root of 2 to the power of 4. Now, how you can remember this law? This is also where it comes from, the word. It can be helpful, the word root. This is a to the power of. I'm not so good at drawing, but we will try do it. So basically this is a tree, and an easy way to remember it is, if this is the fraction, the root, the number down is the root, so you put m here. So 5 is the root of the tree, 4 is the branches, the index. So if I will make it more interactive, the root, a to the power of the branches. It's a good way to remember it. Let's see it. Now, these are all the basic equations. I can go further with some more complicated forms. So basically, if I have a fraction 2 over 3, sorry, let's see it with the general formulas. A to the power of m and all to the power of n is equal a to the power of m times n. An example, 2 to the power of 3 to the power of 2. This is 2 to the power of 3 times 2, which is 2 to the power of 6. The other one is a to the power of m times the same base, a to the power of n. It's equal a to the power of m plus n. So an example, 2 to the power of 3 times 2 to the power of 5 is going to be 2 to the power of 3 plus 5, which is 2 to the power of 8. Obviously, the same laws apply if I have a fraction. A to the power a over b to the power of m is going to be a to the power of m over b to the power of m. So this one, the index goes to the numerator and to the denominator. 2 over 3 to the power of 3 is equal 2 to the power of 3 over 3 to the power of 3, which is 8 over 27. Some extra important, more tricky problems. Let's say I have 2 over 3 to the power of minus 2. It doesn't change anything, so basically it's 2 to the power of minus 2 over 3 to the power of minus 2, which is 1 over 2 to the power of 2 over 1 over 3 to the power of 2. And here I can use again the simplification of the composite fraction, 3 to the power of 2 over 2 to the power of 2, which is 9 over 4. So you see, basically, whenever I have a fraction to the power of minus, it's like having 3 over 2 to the power of 2, which gives me 3 to the power of 2 over 2 to the power of 2. Very important properties. And I can also have, for example, 4 to the power of minus, let's say 4 over 3, which is here. Now this minus, I will move it on the numerator, minus 4 over 3, and then I can say, I use my property, third root of 4 to the power of minus 4, and then I will continue inside here, square root, cubic root of 1 over 4 to the power of minus 4. You see here, I just continue my properties here. So this one became this one, which is, on the other side, square root third root of 1 over plus, which is third root of 4 to the power of 4. Very important expressions. And the next topic will be the exponential equations.